Hey everyone! Welcome back to Network Academy Fun, where we learn to become data center engineers while having a good time. Today's lesson: the Superhighway system, unpacking spine leaf data center topologies. Hey network explorers! Today we're diving into something super cool and fundamental to modern data centers. Spine leaf topologies. Imagine trying to build a bustling city. You need good roads, right? Well, a data center is like a digital city, and its roads determine how fast and efficiently data can travel. We're going from dusty backroads to super slick expressways. Before we talk about the future, let's peek at the past. Traditional data centers often used a three-tier design: access, distribution, and core. Think of it like this. To get from your house, server, to your friend's house across town, another server, you might have to go through local roads, then a main artery, then downtown, then another main artery, and finally local roads again. Lots of detours, lots of potential traffic jams, especially if everyone's trying to go downtown. So, how do we fix those traffic jams? We redesign the city. Spine leaf is like throwing out the old, winding streets and building a brand new, highly efficient highway system where every local road has a direct on-ramp to * multiple superhighways. It's all about creating a flatter, faster, and more scalable network structure. No more unnecessary detours. At the heart of our new city grid are the spine switches. Think of these as the main, high-speed, non-blocking interstates or superhighways. Their job is simple: move data as fast as possible between other layers. They don't connect to servers. They're purely there to provide super-fast connections to * everything else. Each spine switch connects to * every single leaf switch, creating a massive, interconnected backbone. Now for the leaf switches. These are like our local streets and on-ramps. Servers, where your apps and data live, connect directly to leaf switches. And here's the magic: every leaf switch connects to * every spine switch. This means any server connected to any leaf switch has a direct one-hop path to any other leaf switch via a spine switch. No bottlenecks, just smooth sailing. In a data center, data traffic moves in two main ways: north-south, like a user outside the data center accessing a server inside, and east-west, like two servers within the data center talking to each other. The old three-tier model was okay for north-south, but east-west traffic often had to bounce up and down the hierarchy. Spine leaf is a superstar for east-west traffic, making server-to-server communication incredibly fast and efficient because it's usually just one hop across a spine. So, why bother with this fancy new design? Benefits galore. 1. Scalability. * need to add more servers? Just add more leaf switches and connect them to * all existing spines. Super easy expansion. 2. Low latency. * data has fewer hops, so it gets where it's going faster. Zoom. 3. Resilience. * if one spine goes down, there are still plenty of other spines for data to use. No single point of failure. 4. Simplified management. * often easier to manage and automate compared to the tangled mess of the old way. It's a win-win-win. Boom! You just got a crash course in one of the most critical network architectures out there. You're practically a data center urban planner now. Understanding spine leaf is a huge step in seeing how modern networks are built for speed, efficiency, and growth. Keep those questions coming, and let's keep building our network knowledge superhighway. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.